Wait, how did the universe come to be?
For a long time, people assumed the universe was infinitely big and infinitely old. These assumptions posed a problem, called Olber's paradox. Picture looking at a forest. You can't see anything past the forest because anywhere you look, a tree falls in your line of sight. The same concept applies if the universe were infinitely big and infinitely old. Anywhere we look, a star would fall in our line of sight in the sky. So instead of the sky looking like this, it would look like this, except more blinding. Seeing as I don't have to wear these nifty solar eclipse glasses wherever I go, Olber's paradox poses a serious issue. However, the Big Bang Theory says that there indeed was a beginning to the universe. This solves Olber's paradox because the light from distant stars just hasn't had enough time to reach us yet. And as for this, well, we'll get to that later. Let me walk you through 3 key pieces of evidence that the Big Bang occurred. In the 1920s, Edwin Hubble observed distant galaxies and noticed that they were redshifted. Red light has the longest wavelength on the visible light spectrum, so these light waves are being stretched apart, indicating that these galaxies were moving away from us. Hubble measured that their redshift was directly proportional to their distance from us, which means that the farther away the galaxy gets, the faster its precession velocity. This means that the universe is expanding. Say hello to our universe. As we know, it's expanding. So what happens if we reverse the clock? The universe must have been infinitesimally small and infinitely hot at one point, the moment of the Big Bang. Now on to number 2. From the singularity that the Big Bang started from, the universe began to expand and cool rapidly. Quarks, antiquarks, antileptons, and leptons, such as electrons, formed, and later quarks combined to form baryons, such as protons and neutrons, and antibaryons. By the time the universe was 1 second old, photons did not have enough energy to create baryons, leptons, and their antimatter counterparts anymore. Baryons annihilated with antibaryons, and leptons and antileptons did the same. There was a slight asymmetry of matter over antimatter, so baryons and leptons were left over that created all of the normal matter we see today. By 100 seconds, protons could bond with neutrons. Since most neutrons had decayed to protons, for every neutron there was 7 protons. They bonded to form helium nuclei. A helium nucleus is about 4 times as massive as a hydrogen nucleus, which means the ratio of normal matter in the universe was about 75% hydrogen and 25% helium. This is precisely the ratio we see in stars and nebulae today, which is more evidence that the Big Bang Theory is correct. Finally, on to number 3. After 300,000 years, electrons and nuclei began to combine. Since no more free electrons could scatter photons, the universe went from opaque to transparent and radiated infrared light. The Big Bang Theory predicted these photons expanded with the expansion of the universe and should now be microwave radiation. In the 1960s, scientists setting up a satellite dish detected a constant static hiss. What they initially thought was emanation from pigeon poop was actually cosmic microwave background radiation. This accidental discovery further solidified the Big Bang. The Big Bang Theory still leaves some questions unanswered. For example, we're still unsure of the shape of the universe, whether it's infinitely big or not. I guess that's up to you and me to think about.